बच्चों एक बात बताता हूँ सबसे पहले तुम लोगों को कि तो सबसे पहले मैं तो अपने बारे में थोड़ा इंट्रोडक्शन कर लेता हूँ सिंस दिस इज आवर फर्स्ट क्लास तो आई एम शोभिक तरफदार ओके so Oishani and you and me we are actually sharing the same kind of surname okay so let's start then चलो स्टार्ट करते हैं हमारा चैप्टर just a moment okay students tell me once that can you see my screen okay
Yes, sir.
so we are going to start chapter light okay तो सबसे पहले अगर लाइट के बारे में बात किया जाए कि क्या होता है क्या व्हाट इज लाइट ओके एक अगर कोई तुम एक वर्ड में बोलने की कोशिश करो एक वर्ड ओके वन वर्ड लाइट के लिए खर्च करेंगे ओके तो उसके बारे में थोड़ा बताने की कोशिश करेंगे तो कोई बता सकता है इन वन वर्ड व्हाट विल बी लाइट उसके बाद तो ऑब्वियसली उसको लेके और भी हम लोग एक्सप्लेन करेंगे लेकिन एक वर्ड में लाइट को क्या कहा जा सकता है कोई आइडिया
Sir, energy. It's a light is a form of energy.
एग्जैक्टली लाइट इज अ फॉर्म ऑफ एनर्जी बच्चों देखो अगर जब से फिजिक्स हम लोग पढ़ते आ रहे हैं साइंटिस्ट जब से अलग अलग चीजें फिजिक्स के डिस्कवर करते जा रहे हैं सबसे पहले ना एनर्जी के फॉर्म में सबसे पहले हम लोगों को जिस फॉर्म का एनर्जी मिला वो था हीट एनर्जी उसके साथ साथ मैकेनिकल एनर्जी ये सब एनर्जी हम लोगों को मिलता गया ओके नो जैसे हम लोगों ने देखा था कि अगर एक स्टोन लेके तुम तालाब में फेंको तो वहां पे एक रिपल पैदा होता है ना एक रिपल होता है तो वो रिपल एक वेव फॉर्म में पैदा होता है जो रिपल होता है उसका एक साइनूसॉइडल एक वेव होता है मतलब उसका जो फॉर्म होता है वो दिखने में अगर तुम तालाब में फेंको तो दिखने में वो ऐसा वेव पैदा होगा है ना ऐसा ऐसा टाइप ऑफ वेव पैदा होगा वहां पर अलग अलग डायरेक्शन में तो इसको ऐसे वेव को हम लोग क्या बोलते थे क्योंकि हम लोगों ने एक स्टोन फेंका ठीक है ना तो ऐसे वेव को हम लोग बोलते थे मैकेनिकल वेव ठीक है ना अब देखो हमने देखा कि अगर तुम एक ऑब्जेक्ट को लेके तुम सोचो उसको बर्न कर रहे हो या हीट कर रहे हो सोचो तुम्हारे पास एक रॉड है एक मेटल रॉड है और उस मेटल रॉड को तुम हीट कर रहे हो अब जब तुम इस मेटल रॉड को हीट करोगे वो मेटल रॉड एक टाइम में जाके उसमें से लाइट निकलेगा है ना उस मेटल रॉड का जो कलर होगा वो कलर चेंज करता रहेगा एंड वंस इन अ सर्टेन टेम्परेचर वो वहां से हमें लाइट बाहर आता हुआ दिखेगा तो यहां से हम लोगों को जो मतलब साइंटिस्ट लोगों ने जो डिसाइड किया कि अच्छा मैं क्या दे रहा हूं वो जो रॉड था हमारे पास जो जो मेटल रॉड हमारे पास था जहां पर हम लोग ऐसे आग से हीट दे रहे थे तो हम लोग दे क्या रहे थे दिस वाज अ मेटल रॉड ओके ना मेटल रॉड तो आग से कौन सा एनर्जी दे रहे थे हम लोग हीट एनर्जी हम लोग प्रोवाइड कर रहे थे ओके हम लोग हीट एनर्जी प्रोवाइड कर रहे हैं और ये जो हीट एनर्जी हम लोग प्रोवाइड कर रहे थे, इस हीट एनर्जी से इसका टेम्परेचर बढ़ रहा था। एंड आफ्टर अ सर्टेन टाइम हम लोगों ने देखा ये जो मेटल रॉड है ये सिर्फ हॉट ही नहीं हो रहा है, सिर्फ इसका हीट ही नहीं बढ़ रहा है, उसके साथ साथ ये लाइट एनर्जी भी एमिट कर रहा है। ये लाइट एनर्जी भी एमिट कर रहा है, मतलब लाइट एमिट कर रहा है। लाइट, सबसे पहले तो हमने ये देखा कि लाइट एमिट कर रहा है। अब देखो, क्योंकि यहाँ पर हमने हीट दिया था एंड ऑलरेडी तब तक हीट को इन द फॉर्म ऑफ एनर्जी पकड़ा जाता था, तो वहां से हम लोगों को लाइट मिला। तो
So can I explain in
एक
either English or Bengali?
अच्छा, जस्ट अ मोमेंट। अच्छा, so is it fine if I talk in English or Bengali will be fine for you?
Yes, sir.
Wait. Okay, chalo. So just a moment. So students, by that time, what happened that already we considered heat in the form of energy. Okay, no. So what we saw that we are getting light from heat energy, isn't it? So from there we concluded if we can get we can get light from heat, then we can say that light is also a form of energy. तो from there वहां से हम लोगों को समझ में आया, from there we got that light is also a form of energy. Okay, अब देखो, since light we considered as a form of energy, that's why whenever this is the energy does what? Energy propagates. Okay, no, energy एक जगह से दूसरे जगह तक वो move करता रहता है. Energy propagate from one place to other place. Like what? Like what? Suppose if you are burning some coal in a particular place, isn't it? See, if you are burning, like, let us take here, there is a oven. Okay, a gas oven here you have been kept. This is a gas oven. Now this gas oven, if some थोड़ा सा अमाउंट में अगर यहाँ पे आग जल रहा है, ओके ना, इफ वी आर बर्निंग समथिंग ओवर हियर, आफ्टर सम टाइम यू विल बी एबल टू फील heat over here also. In the surrounding places you will be able to feel heat, isn't it? Like suppose if mummy is cooking some food in the kitchen, isn't it, at that time the kitchen becomes hot, isn't it? That's why mummy got, means she got sweat, isn't it? Why that happened? Because when the gas is burning, no, at that time that heat propagates from not only, means from the gas to the entire kitchen, isn't it? So what happens actually, it any energy, just a moment. Okay. So any energy, it propagates from one place to other place. Now at that time we used to know there is that how energy propagates in the form of wave. Okay, no, energy propagates in the form of wave. ये हमने कहां पर देखा? Where we have seen this? See, when we put a stone into pond, at that time we have seen ripple, we have seen waves like this, isn't it? So what actually propagates over there? The energy what you have given on the stone, that energy actually propagates from here to here. Understood? Clear, students? So in the same way, heat also propagates. So that's why we concluded. So obviously light will also propagate in that similar way, isn't it? Though later some other kind of formats also came, okay, other kind of thoughts also came, okay, what we at this moment we consider. But at that time we used to think that light is actually propagate in the form of wave, okay. So that thing we know, one thing we understood, that what is light? Light is a form of energy. So since it is a form of energy, it can convert from one form to other form. It can propagate from one place to other place, isn't it? So that actually happens. Okay. Now, students, can you see this? The this page, can you see, students?
Yes, sir, I can.
Great. Just a moment. Now see one thing. So later we discussed that light is not this kind of wave. Okay, no? Light is not as simple like this wave. Light is what kind of wave? It is a electromagnetic wave. It is what kind of wave? Light is
An electromagnetic wave, sir.
light is an electromagnetic wave. We also call it as EM wave. Why we call it? What is the difference of an EM wave than a mechanical wave? Let me show you that. Okay, no? See, if there is a mechanical wave, it actually propagates like this. It propagates. It propagates like this. And let me tell you, if this is a mechanical wave, then for a mechanical wave to propagate, a mechanical medium is must. Without a mechanical medium, a mechanical wave can't propagate. Now you will ask, sir, what is mechanical medium? Mechanical mediums are such medium where in the particles of the medium, some intermolecular force acts. Okay, no? In the particles inside the medium, like air is a mechanical medium, water is a kind of mechanical medium, okay, no? Because the intermolecular force between two particles, two water particles or two air particles are there, okay, no? So that's why if you disturb at a particular point, suppose if I am putting a stone into pond and due to that the stone is disturbing a particular point, let us take stone is disturbing this point, due to the, but stone is not disturbing this point, but how this point is also oscillating, because the, when this point is disturbed, no, at that time due to the disturbance of this point, the point beside this also oscillating, the point beside this also oscillating, okay. See, actually, a question came into scientists' mind that if light would be this kind of medium, light would be also a mechanical medium, then how light is propagating from sun to earth? Because between sun and earth, there is a place in between which is absolutely vacuum, yes or no? And since mechanical wave need a mechanical medium to propagate, there too it is vacuum, then how light propagating from sun to earth? Then we actually came to, means then actually we got to know a new thing. At that time scientists concluded in this way that in the entire universe, they actually concluded in this way, in the entire universe there is a medium known as ether medium. What medium? Ether medium, okay. So they actually told in this way, light propagates through the ether medium, okay. But later two scientists, okay, no, their name is Michelson Michelson and Morley. They actually did one experiment, and using that experiment, they actually shown what? That there is no such medium in the universe. So actually Michelson and Morley proved the non-existence of ether medium. They did what? They proved the non-existence the non-existence of ether medium. Okay. Now see one thing. After that, scientists actually concluded the the new theory. What actually we till now we actually go with that theory only. That is what? That is the electromagnetic theory. At that time, they thought that light is what kind of wave? It is not a mechanical wave. It is a light is a kind of electromagnetic wave, EM wave. Now, EM wave doesn't need any medium to propagate. It doesn't need any medium to propagate. Any medium to propagate. Now, if I try to draw uh, electromagnetic wave over here, then I'm trying to show you people. Okay. See here, the wave, electromagnetic wave actually propagates in this way. I'm just trying to show this. I'm just trying to draw a three-dimensional diagram. Now, students, if you see here properly, see, can you understand these waves? They are actually, if this is I'm taking x-axis, this is y-axis, and this is z-axis. The black ones, the black waves, okay, no, they are containing the x and z plane, and the red waves, they are containing the xy plane. Can you understand this thing from this diagram, students? Tell me. See, the black ones, they are containing the x and z plane, and the red ones, they are containing x and y plane. So these are the kind of EM wave, electromagnetic wave. And if I show you over here, if you see this, can you see it, students? Can you see this diagram? So this is also, they also have shown in the notes also, this is the way they have drawn the electromagnetic wave. So actually, in case of now, I'm actually trying to show you using my hand. Okay, no? Can you see, students? Can you see? See, my hands can be, you can see it. You can see my hands.
Yes, sir.
Now, see here. See here. In electromagnetic wave, there are two waves simultaneously propagating. One, it is propagating like this. One is propagating like this. And the other, it is propagating like this. Okay. Did you understand? One is going in X and Z plane, up and down vertically. It is going vertically. And this is going horizontally. Students, this is going horizontally. Can you understand, students? That one is going in this plane like this, and the other is going like this. It is going like this. Am I clear, students? Am I clear? Now, you see it once again. Now see here. Now try to see it that these red ones, they are containing X and Y plane. And the black ones, they are containing X and Z plane. So this is the kind of EM wave. Okay, students, is it clear? बच्चों बताओ, is it clear? Hello?
Yes, sir. Yes.
Oh, great, great. तो अभी हम लोग आ जाते हैं हमारे नेक्स्ट टॉपिक. ओके, व्हाट इज द नेक्स्ट टॉपिक? द कैरेक्टरिस्टिक्स ऑफ लाइट. अभी लाइट के कैरेक्टरिस्टिक्स के बारे में भी थोड़ा पढ़ना पड़ेगा. ओके, व्हाट इज द कैरेक्टरिस्टिक्स ऑफ लाइट? दैट आल्सो we will study over here. Okay, see, as you can see here, that what is told, what are the characteristics they have discussed about, that light can travel along a straight line. Okay, light actually travel along a straight line in a medium or vacuum. So light can travel in any medium or also in case of vacuum. So either it is a medium, means like glass, like water, like air, like glycerine, any kind of medium. If it is a transparent medium, light can pass through it. Okay, light can propagate through that medium. And also if it is a vacuum, means space, when light travels from sun to earth, okay, or when light is traveling from, in that case also light is traveling through vacuum. So light can travel in both the places, either through vacuum or through any other medium. Okay, students. Now coming for the next one, that light travels with speed nearly equal to 3 to 10 to the power 8 meter per second. Now let me tell about this thing. The speed of light in vacuum, in vacuum, that is equal to 3 into 10 to the power 8 meter per second. 3 into 10 to the power 8 meter per second. And let me tell you, this is the maximum speed of light anywhere in the universe. And let me tell you, not only the maximum speed of light, this is the maximum speed ever possible. Okay, no? Of any object or any wave, whatever it is, this is the maximum velocity or maximum speed. Speed more than this speed is not possible. Okay, more than this speed, more than 3 into 10 to the power 8 meter per second, no, it's not possible. Okay, and let me tell you, this speed we call as c. Okay, we denote this speed as c. C is what? If someone says what is the speed of light in vacuum, we can say the entire value 3 into 10 to the power 8 meter per second. Also we can say it is c, or means we can say it is c, or we can say the value. Okay, so that is the speed of light in vacuum. But let me tell you, in other medium, it is not equal to c, it is lesser than c. Okay, so in vacuum, this is the maximum speed, this is the maximum speed. Okay, and in other medium it is lesser than c. In other medium, it is lesser than c. Okay, any other medium, suppose you are going for, I'm just giving as an example. Okay, later we will, means there are numericals where we can find the speed of light in other medium also, in glass, in water. Okay, no? We can find in this class only. We will means in class 10 only we will study about those things. We will learn about those formulas. Okay, no? So in other medium, let us take glass. The speed of light is 2 into 10 to the power 8 meter per second. Maybe in glass medium, speed of light will be 2 into 10 to the power 8 meter per second. Okay, that also happens. Okay, so medium to medium, the speed of light changes or differs, but the speed of light in vacuum, that is this much, and it is constant, and it is the maximum speed possible of anything. Okay, more than this speed is not possible in the entire universe. Let me tell you. So isn't it interesting, the speed of light? And let me tell you, from the speed of light, no, this entire new kind of physics starts. Okay, no, like relativity, like quantum physics, what we actually study in higher classes. Okay, so students, now is it clear? So till whatever I have told, was it clear, students, for you? Tell me, Shutapa, sorry, Shubhayan and Oishani, was it clear?
Yes, sir. Clear.
Okay. So now coming for the next character, the speed of light waves depend on the medium through which they pass. Obviously, see, the more the medium is, the more denser the medium is, the speed of light is lesser. Okay, no? When the medium become more denser, the speed of light in that medium will become lesser. That's why, since in vacuum nothing is there, no particle is there inside the vacuum, that's why speed of light in that medium is the maximum. Okay, now whenever medium is denser, the particles of the medium is closely spaced, they are very close to each other. Okay, no, at that time, the speed of light also decreases. Am I clear, students, am I clear? You can even keep your mic on, because only means two of you are there. Okay, so you can keep your mic on, so
Okay, sir.
whenever I will ask you, you can answer. Oishani, also you can keep your mic on. So now coming for the next, light shows different behavior such as reflection, refraction, interference, diffraction, polarization. And let me tell you, all these things we will know, means most of these things we will know in class 10. Like we will know in this chapter, we will know about reflection, we will know about refraction, we will know about dispersion. Okay, we will know about scattering. Okay, all these are the phenomena of light. Okay, now also there are few phenomena why what we will not study in a deeper way in this class, that is interference, diffraction, polarization. These things we will study in class 12. Okay, no?
Okay, sir.
It means deeper, in a deeper way. Okay, no? So now, one last thing I would like to say about the propagation of light. See, how light propagates, that you already understood. That you already understood. What is that? How
Sir,
it
light travels
propagates?
in a light travels in a straight line.
Light travels in a straight line. But if light is traveling in a straight line, but here though I have shown that light is traveling like this. So how we can say light travels in a straight line? Light the traveling is like this, means like a wave, like electromagnetic wave. So how can we consider that light is traveling in a straight line? See, that I'm showing. See, though the light is traveling like this, okay, but at last it is actually moving along which direction? If light is traveling in this way, like in this manner, at last light is traveling in which direction?
Sir,
If you
along a straight line like direction only.
So yes, so at that time, if you see that the light is actually traveling, if you add all these points, if you add, suppose this point you are adding, then this point you are adding, then this point also you are adding, okay, no, then you will get this straight line, okay. So that is the direction of propagation of light, and that's why we say that light is traveling in a straight line, okay. And let me tell you one thing, that if you add these points, the straight line you are getting, do you know what is the name of this straight line? What we call this is called light ray. Light ray, or the ray of light, okay, no. So this is known as light ray. Am I clear, students? Am I clear? So from now onwards, no, whenever we will say that light is propagating, we will not draw so many things. We will not draw waves like this. What we will draw? We will draw simply, some lines. Maybe light is this. This is ray of light. Okay. This is what? The ray of light. This is, and we will show the arrow. Arrow will show what? Along which direction the light is propagating. So light ray actually is a straight line which shows the direction of propagation of light waves. Am I clear, students? Am I clear? So these are the light rays. Is it clear? Shubhan, clear?
Yes, sir.
Great. Oishani, clear? No?
Yes.
Great. Okay. So now coming for the next topic. See, already we started. Now we are going to properly know about the ray and the beam. Okay, ray and beam of light. See, I already started telling about light rays, right? Isn't it? So now light ray, you already understood what is light ray, isn't it? So light ray and light and beam of light, about that we will know now. Okay, light ray and beam, light ray and beam. Now, what is light ray? That I already told you. Okay, the straight line which shows direction of propagation of light, isn't it? So we can even write in this way that the straight line which shows the direction of propagation of light. Okay. Now, what are the kinds of light? And so this is light ray. Okay. Now, what is beam? What is beam? See, if together many light rays are there, that is known as beam. Okay, no? Beam of light. Okay. See, if together, let us take many light rays are there. Like this is a light ray, then this one is a light ray, then this one is a light ray. Okay. So there are three light rays together. Okay, no? So together these three light rays will be known as beam. Will be known as beam. Am I clear, students? Am I clear? Now, I would like to tell you the different types of beam. Okay, no? What are the different types of beam that I will tell you? Okay, no? See, first it is parallel rays or parallel beam. You can say parallel rays or beam. Parallel rays or parallel beam. How we draw it? See, if there are light rays, those who are parallel to each other, see, those who are parallel to each other, they are known as what? They are known as parallel rays or parallel beam. Am I clear, students? Is it clear? See,
Yes,
all
sir.
the waves are actually propagating into a particular direction, okay? All their directions are same, so that's why we are calling them as parallel rays or parallel beam, okay? Coming for the next type, next is, so this is the first type. The second type, the second one is known as convergent beam. Convergent beam or convergent rays also we can say. What is the meaning of convergent? Can anyone tell me convergent meaning? Convergent meaning in Bengali or in English, whatever you want, you can tell. Okay, tell me. बता सकते हो किसी भी लैंग्वेज में, যে কোনো ভাষাতে বলতে পারো। What is convergent? Okay, any idea, students?
Sir,
What is
convergent rays are those light rays which get emitted from a point.
emitted from a point? Acha, any Oishani, you want to say anything about convergent? Convergent. See, students. Yeah, Oishani. Yeah, you can answer if you want. Okay, I'm telling you. See one thing. What is convergent? Whatever actually Shubhan you told na, that is actually the definition of divergent. Okay? See, what is convergent? Which is actually converging or meeting at a particular point. Converging or meeting at a particular point. Like if I show the diagram, then convergent means it is, sorry, convergent means it is meeting at a particular point. See, students, these three rays, aren't they meeting at this point? Aren't they meeting at this point? So these three rays are convergent rays or convergent beam. Am I clear, students? Shubhan, clear, no?
Yes, sir. Clear.
Now the divergent, what you told, that was divergent. Okay, now coming for the divergent one. The third one is the divergent. Divergent beam. What is divergent beam? Divergent means, see, from the, let me tell you, since this is the first class, now I used to say this thing to the students that, like, Shubhayon. Shubhayon, can you please tell me your name? The meaning of your name. Can you please tell me what is the meaning of your name?
I think it's an auspicious beginning. I think.
Okay, auspicious beginning. Okay, nice meaning also. See, in case of human, okay, no, our name, the meaning of our name, it is not necessary that always the meaning of our name will be equal with our characteristics. Okay, like people are there, okay, no, whose name is actually doesn't suit with their characteristics. We have seen names like that, isn't it? But that does not happen in case of science, in physics, okay, no? If you, why do you know why that happened? Do you know? Because for us, for humans, whenever we born, at that time the name is being given already. The name is done, given. but after that we actually build up our characteristics, isn't it? So that's why it may differ from our name, from the meaning of our name. Okay. But in case of science, whenever something is being invented, first it is invented, then the name is given, like the name of a movie. सोचो अगर कोई मूवी का नाम हो, now if the name of the movie is एवेंजर, ओके ना, तो एवेंजर नाम सुन के लग रहा है कि हाँ कुछ तो मारपीट का मूवी होगा, इट विल बी अ काइंड ऑफ एक्शन मूवी, और स्टार वॉर्स तो नाम सुन के ही लग रहा है कि देयर विल बी सम काइंड ऑफ like sci-fi movie. Means some kind of stars will be there and there some aliens could be there, okay, no, there something will happen, isn't it? So, why that happens? Because at first the movie is being made and then the name is suggested. The same thing happened in case of science also. First, the thing, the theory, the definition is being invented, then they have given the name. Okay, no? That's why if you think about the name of the thing, then also from there many information you will be able to get. So in a similar way, like convergent, if you see the meaning in dictionary, in English meaning or in Google, you will see something meeting at a particular point. Okay. You will get this kind of meaning. Okay. In the similar way. So that's why this is my recommendation to you people. Whenever you are reading some theory of physics, of science, first see the name and try to get the meaning of the name. At least 30% you will understand from the name itself. Okay. So now coming for divergent beam or divergent rays. Okay. So divergent means it is diverging, means from one point it is going away from each other, like this, like this. So these are known as divergent rays or divergent beam. So these are what? Divergent beam. Because they are actually started from this point, and from this point they actually going away from each other. So this is known as divergent beam. Am I clear, students? So the three kinds of beam: the parallel, the convergent, and the divergent. Now coming for the next topic. Okay. Now, if I tell you the kind of source, now coming for reflection of light. Okay, no? What? Reflection of light. See, in characteristics, we already studied that there are few phenomena of light. What was those phenomena? What I told. So, any one of you remember the phenomena? At least tell me one, two phenomena of them. The characteristic, the phenomena what light have. I told you that some of them we will study in class 10, some of them we will study in class 10, class 12.
Sir, I think polarization, diffraction.
Polarization, diffraction, yes, you remember these things, right? Polarization, diffraction. Okay. Anything else, Oishani? You want to try any other name? Do you remember? Okay, so I'm telling, reflection was there, isn't it, Shubhan? Reflection,
Yes, sir.
refraction, dispersion, scattering. Okay, so
Yes.
now the first phenomena of light we will study, that is known as what? Reflection. That is known as what? Reflection. Okay. See, what is reflection? What is the meaning of reflection? See, now I told you already that whenever I will say light is propagating, at that time we will show the propagation of light using what? Using what?
Straight line, sir.
Yeah. And what is the name of that straight line?
Rectilinear propagation.
No, rays. They
Oh,
are
sorry, rays.
light rays, isn't it?
Rays, sir.
Okay. So no, it's fine. So just keep on, means then only it will be a kind of class where both of us we are interacting, isn't it? So now what is reflection, that I will show you. See, first let me draw a diagram. Uh, See, think this is a lake, okay? This is a lake, okay? So students, tell me one thing. If this is a lake, then here, what is this? Which medium will be here? Can you tell me?
Sir, water.
Yes, obviously. Water medium will be here. Here it will be, here it will be water medium. Acha, and here which medium will be? In the above of water medium, which medium will be there?
Sir, air.
Very good. Air medium will be there, isn't it? Now see one thing. This portion, this the red line, okay, no, where I have given some this amount, okay, no, these things I have drawn. This is known as interface. What we call it? Interface or reflector, okay, no? What we call interface or reflector. Why we call it interface, and what is interface? Where one medium end and the other medium start. So interface means what? Interface. Interface is where where one medium ends and other medium starts. See here, you can say that air medium ending here and water medium starting, or you can say in the opposite way also, that water medium is ending and air medium is starting at this line, at this plane, isn't it? So that is known as interface, and we can call it as reflector also. Okay. Now see one thing, all of you, means both of you, have seen lakes, isn't it, or a small pond in your locality. Now if you go in front of the pond and if you see, and if at that time there is not much wind is blowing, at that time won't you be able to see your reflection, your image on the water surface? Have you seen it? Have you seen your image on water surface?
Yes, sir.
That is reflection. That is the real example, real life example of reflection. Okay, but how that happened, how actually that happened, that I will tell you. Okay, see one thing, before telling that I would like to say you one thing, that how you can see any object. Can you tell me how you can see any object? How you can see any object?
So when the reflected light from the object enters our eye.
Yes, means if this is, suppose if this is, let us take this is Shovik sir. I am this. This one is me. Okay. This is Shovik sir. Okay. And this is uh, Shuhaim. This is Shubha ion. Now, and let us take, this is a source of light. Let us take, this is sun. Okay, no? You can consider it as sun. Source of light. Now, from the sun, light will come, will fall on me, and then it will actually move into other, means all the direction. It will go like this, it can move like this, it can even go like this, or it can go towards you. Okay, it can move towards your eye, it can move towards, sorry, can move towards you. Okay, so in that way also it can move. So it is going into all the directions, all different directions, like this, like this, like this, like this. And from where light is coming? From the source. From the source light, if light is falling on one object or one person, and then after that it is going into some other person. Okay, and if it is moving into the eyes of some other person, then only the object will be visible. Okay, now since light is falling on me, and after reflection light is actually going to you, okay, on your eyes, that's why you can see. If it will not happen, then I will be invisible. If anyhow light is not reflecting from me to your eye, then you will not be able to see me. Am I clear? So now coming for the reflection part. Okay, see here, if are falling light rays are falling on this medium. Okay, on the interface, I should say, on the interface light rays are falling, then what will happen after falling? When it will actually bounce back in the previous medium, bouncing back in the previous medium, that phenomena is known as reflection. That phenomena is known as what? Reflection. Am I clear, students? So once light is actually, first light was propagating where? Propagating where? In air medium. Then it incident where it incidented? In the reflector or in the interface. After that, what happened? It bounced back into the previous medium. The bouncing back of the light rays, once it incident in the reflector, on any reflector, the phenomena of bouncing back is known as reflection. Am I clear, students? Am I clear? Hello?
Yes, sir.
Shubha? Yeah, okay. So that is known as reflection. Okay. Now coming for the next topic. See, actually next topic means it is actually connected with reflection. Reflection also has two types. The types of reflection, if we know the types of reflection. Okay. See, there are two types of reflection. First, regular, regular reflection, and second, diffused or irregular reflection. Irregular or diffused or diffused reflection. Okay, students? So these are the two kinds of reflection. Now we will know about these things. But to know about these things, before we need to know about types of reflector. What? What? Types of reflector. Types of reflector. Students, let me ask you one thing. why you need a reflector? Can you tell me why you need a reflector? Why you need this? Why you need this? Why you need a reflector? Can you tell me?
So that the incident rays can get reflected on that reflector and enter our eye.
So that is the sure that without a reflector you can't have reflection, isn't it? So for reflection, reflector is must. Okay. So since reflector is must, so the kinds of reflector also you need to know. Do you know why? Because on the basis of the types of reflector, the type of reflection also change. Type of reflection actually depends on what? The type of reflector. Okay, let me show you this. Before studying regular, irregular or diffuse reflection, we will know types of reflector. So there are two types of reflector. One is optically smooth, optically smooth, and the other is optically rough. Optically rough. Okay. So these are the two types of reflector. Now, what is the meaning of smooth and rough? So you know, na? Can you give me example of a smooth surface? Example of a smooth surface. Can you tell me?
Sir, mirror.
Okay. Anything else apart from mirror? Example of a smooth surface. Suppose your floor is smooth or rough. Your floor is smooth or rough. Hello.
Sir, at least in our house, the floor is rough.
Achha. Okay. Tell me the board in school, the blackboard or the whiteboard in school, is it smooth or rough?
So that's rough.
That's rough. Okay. Uh, suppose your the mobile surface, the mobile. Suppose this is the mobile, no. So the surface of this mobile, is it smooth or rough?
I think sir, partly smooth. I think.
Partly smooth, right? See, let me tell you one thing. There is a kind of difference between smooth and optically smooth. What I told? There is a kind of difference between smooth and optically smooth. If you see, just a minute. If you see, then many things in your home is smooth. Like your floor is smooth, your wall is smooth. Many surface, what is smooth? Suppose if you go outside, suppose maybe if you see the roads in Behala, okay, no, that is absolutely rough, okay, no? Full of potholes, isn't it? But in terms of light, the optically smooth and optically rough has a different meaning. See, optically smooth, optically rough means what? Smooth or rough with respect to smooth or rough with respect to लाइट ओके ना लाइट के रेस्पेक्ट में ये अगर स्मूथ है तब हम उसे स्मूथ कहेंगे ऑप्टिकली ओके नो सो लेट मी टेल यू वन थिंग व्हाट इज ऑप्टिकली स्मूथ एग्जांपल ऑफ ऑप्टिकली स्मूथ सरफेस इज व्हाट example of optically smooth surface is what example will be mirror plain water surface plain water surface remember not at that time when wind is blowing at that time the water surface is also not optically smooth okay no so these are optically smooth surface okay but optically rough is all other things are optically rough okay like floor your blackboard, etc. Any other object you see, that is optically rough. Okay. Now see one thing. Now coming for now, so you understood what is optically smooth and optically rough. Okay. Now coming for regular and irregular reflection. Now let me tell you, regular reflection happens in optically smooth surface. So let me tell you, for regular reflection, you need an optically smooth surface. Okay. Now, what is optically smooth surface? Optically smooth surface means what? Which is absolutely smooth, as I have shown you the examples. Okay, no? Suppose mirror. Okay, this is an optically smooth surface. Okay, now in an optically smooth surface, when light rays fall, light rays when incident, at that time, see light rays incidenting from one side, after reflection it will go into some particular side only, it will not go here and there. Means while it was incidenting, if at that time it is parallel to each other, see it was parallel to each other, these light rays was parallel beam or parallel rays, after reflection also they will remain parallel. Am I clear, students? After reflection also they will remain parallel. So in which kind of reflection this thing happens, that is known as regular reflection. Am I clear, students? Am I clear, students? Is it clear?
Yes, sir.
Now coming for irregular or diffuse reflection. Irregular or diffuse reflection. Now what actually happens for irregular or diffuse reflection? In case of irregular or diffuse reflection, the surface should be optically rough surface. Okay, so optically rough means it will look like this, uber covered. Okay, no? Like this. Okay, so when light will incident in an optically rough surface, what will happen, do you know? Let us take parallel rays incidenting on a optically rough surface. These are the parallel rays. Okay, then what will happen after reflection? Since the surface is rough, after reflection it will go here and there. Maybe this, maybe this is going this side. Sorry, maybe this one is going along this direction, this is going along this direction, this one is going along this direction. So have you seen that after reflection they are not at all parallel to each other? Have you seen it? They are going in different directions, isn't it? So if they are parallel rays, the incident rays, they are parallel, but the reflected rays, they are not parallel to each other. So this kind of reflection is known as what? Diffuse or irregular reflection. Am I clear, students? Tell me. Am I clear?
Yes, sir.
Great. So one thing you understood, for regular reflection, what happens? Means what needed? A optically smooth reflector is needed. Okay, and for irregular you need an optically rough surface.
Typical
Now
rough
tell me,
surface.
huh, now let me tell you one thing, both of them has different type of applications. Both of them. What are the applications of regular reflection? Can you tell me? Applications of regular reflection. Application of regular reflection? Can you tell me what are the applications of regular reflection? First, mirror. You see image on a mirror, isn't it? You see your image on a mirror, because without regular reflection you can't see any image. You can't see any image. You can't see your image. If you stand in front of a wall, on the wall also light rays from you is incidenting and reflecting back, but still you can't see your image. Do you know why? Because what is happening in case of wall? In case of wall, see, irregular or diffuse reflection is happening. That's why if light is going from you, after that, after reflection, it is actually reflected in different directions. It is going here and there. Okay, no? So that's why so less amount of light is coming to you. Using that, you will not be able to see your reflection, your image. Okay, no? But if it is a smooth screen, optically smooth surface like mirror, like plain water surface, then you will see regular reflection, like this kind of reflection. Okay, no? Where certain amount of light will come to you, and due to that you will be able to see the image properly. Am I clear, students? Am I clear? Now see one thing. So any kind of image, any kind of image formation, image formation. So now next coming the application of diffused reflection. Diffused reflection. What are the applications of diffused reflection, student? Can you tell me? Anyone? Any idea? There are, let me tell you, without diffused reflection, no, many things would not be possible. Many things would not be possible. You know why? I'm telling you. Suppose you went in a movie theater. You went in a movie theater. In a movie theater, the screen is what kind of reflector, do you know? Is it a optically smooth reflector or a optically rough reflector? Can you tell me?
Sir, optically rough.
Since it is optically rough, that's why when from the projector light is projected, light is incidented on the screen, since it is optically rough, that's why it is reflected in all the corners, all the portions of the movie theater, and from each and every seat you can see the movie with equal intensity, and that is only possible since the reflector is optically rough. If in spite of a screen, if you are keeping a mirror, no, then do you know what will happen? हॉल का एक पोर्शन देख पाएगा, दूसरा पोर्शन नहीं देख पाएगा, और जो देख नहीं पाएगा वो क्या करेगा? हॉल का चेयर तोड़ देगा, है ना? तो in case of with optically rough surface, actually since after reflection light travels in all the directions, isn't it? That's why it is actually needed in movie theater. Suppose if I'm taking class in a classroom, suppose when everything will be absolutely normal, we will do our class in the center. Okay, no, at that time in the room, if you have went in the center, you must have seen, in that case, if I'm standing in one corner or anywhere, So every student from all the corners of the room will be able to see me, isn't it? Why? Because my surface, my upper surface is an optically rough surface. And since it is an optically rough surface, that's why I am visible from every corner of the room. So did you understand that optically rough surface, to become an optically rough surface is so much important? So there are different kinds of application for optically smooth as well as optically rough. Am I clear, students? Students, am I clear?
Yes, sir.
Great. So optically rough surface, the examples can be shown screen in a movie theater. Okay, students, am I clear? Now coming for the next topic. Okay. Now I'm coming for laws of reflection. Okay. But let me tell you, I'm telling you मतलब एक ultimatum देना चाहता हूँ कि laws of reflection doesn't applicable for diffused reflection. Okay, no? So laws of reflection only applicable for regular reflection. तो अभी diffused reflection को छोड़ के completely हम लोग shift कर रहे हैं कहाँ पर? Regular reflection में. Am I clear, students? So now we completely shifting into regular reflection. So this is a disclaimer. Okay, no? I'm giving you a disclaimer that laws of reflection, laws of reflection is only applicable for regular reflection, or we can say optically smooth surface. Optically smooth surface. Okay, students?
But
So now
sir,
let's uh-huh.
sir, I have learned in school that laws of reflection are applicable for all surfaces.
No, students. I'm telling you. Why? I will see. I'm not telling anything like it only. Okay, no. I will show you proper logic over there, and I will tell you. At that time I will give the answer of this. Okay, no. I'm telling you.
Yes.
Now coming for laws of reflection. See, actually, there are two laws of reflection. There are two laws of reflection. So first, the two laws are named as in this way: the first law and the second. Okay, I will explain you, and then I will make you capable to state the law by your own. तुम लोग अपने आप बोल पाओगे या मैं तुम लोगों से बुला के रहूंगा? देखो, पहले मैं तुम लोगों को समझा देता हूं कि व्हाट इज लॉज ऑफ रिफ्लेक्शन. ओके ना? सी हियर, फर्स्ट आई एम ड्राइंग a reflector. What I'm drawing? A reflector. Now, what is this? This is a this is the normal. Okay, and this is incident ray, and this one is reflected ray. Okay, students, clear? This is the reflector. Always we show reflector in this way. Okay, what is this? This is called as reflector. This is incident ray, so that's why the arrow is given in this direction. This is reflected ray, that's why the arrow is given along this direction. And this is what? Normal. This is what? Normal. Normal means, what is the meaning of normal? Normal means it is a perpendicular on the reflector. Normal is what? Normal is what? It is a perpendicular drawn on the reflector. Okay, students. So what is normal that you understood? So can you tell me how much angle the normal is making with reflector? How much angle the normal is making with reflector? Can you tell me?
Some 90 degree.
90 degree, right? Great. So now I'm talking about the first law. I'm telling you the first law. Acha, see here in this page, I have drawn the incident ray, normal, and the reflected ray, right? In this page, I have drawn, isn't it? Now, can you draw the same thing, this same diagram on your copy? Can you draw this on your copy? Yes or
Yes,
no?
sir. Yes, sir.
Can you draw it on the board? Can it be drawn on the board? Teachers can draw, students also can draw if they are having board or in the school, isn't it?
Yes, sir.
अच्छा, can it be drawn on your wall? वॉल में ड्रॉ किया जा सकता है, हाँ या ना?
No, sir.
क्यों? मम्मी पापा मारेंगे
Yes,
इसलिए?
sir.
हाँ, गुड गुड. अच्छा, मम्मी पापा ना मारे तब तो ड्रॉ किया जा सकता है.
Yes, sir.
ग्रेट. फ्लोर में ड्रॉ किया जा सकता है, like if the means if after means just after that the maid will wipe out the floor. वो पोंछ देगी, ठीक है ना? तो तब ड्रॉ किया जा सकता है ना फ्लोर के ऊपर.
Yes, sir.
अच्छा देखो कहां कहां पर ड्रॉ किया हम लोगों ने. इस प्लेन मतलब यहाँ पे ड्रॉ किया, इस बोर्ड के ऊपर, इस व्हाइट बोर्ड के ऊपर हम लोगों ने ड्रॉ किया. हम लोग ये भी बोल रहे हैं कि ये बोर्ड में ड्रॉ किया जा सकता है, वॉल में ड्रॉ किया जा सकता है, फ्लोर में ड्रॉ किया जा सकता है. एक चीज देखो, ये सारे चीजों में जो जो भी हमने बोला, एक पेज, एक बोर्ड, एक वॉल, एक फ्लोर, इन सारी चीजों में, सारे जो एग्जांपल्स मैंने दिया, इन सारे एग्जांपल्स में सिमिलर क्या है? कोई बता सकता है? व्हाट इज सिमिलर इन दीज एग्जांपल्स? एनीवन कैन टेल व्हाट इज सिमिलर? चलो मैं बताता हूं. See, all these are planes. All these are what? Planes, isn't it? They
Yes,
are
sir.
planes. They are two-dimensional planes. Like this is a plane, this thing is a plane, this whiteboard is a plane, the board in your school is a plane, the floor is a plane, the wall is a plane, you can draw it in the roof, that is also a plane, and all of them is a plane, isn't it? Yes or no? Yes or no?
Yes, sir.
So what I can say, now you will tell, I will only help you to state the first law. What is this? What is this?
The incident ray.
What is this?
The reflected ray.
What is this?
Normal.
So these three can be drawn in a
A plane.
drawn on that is first law. That is first law. So you only told the first law. So the statement of first law will be, the statement of first law is what? The incident ray, reflected ray, and normal. can be drawn on a same plane. Or we can even say the incident ray, reflected ray, and normal and normal lie on same plane or remain on same plane. Okay, no, can be drawn on a same plane, or we can even write apart from this can be drawn on. Apart from this, also we can say or remain on a same plane. Am I clear, students? Am I clear? So this is the statement of first law. You only told. Is it clear, students? Tell me yes or no.
Yes.
Next thing, what I will tell you, that is, see, always remember the angle between incident ray and normal is angle of incidence, and the angle between reflected ray and normal is the angle of reflection. Always remember this thing. What is angle of incidence, students? Angle of incidence, it is the angle between incident ray, I ray, and normal. Okay. And what is angle of reflection? What is angle of reflection? It is angle between reflected ray and normal. Am I clear, students? Am I clear? How we say incident ray, how we denote incident ray? By I. This is incident ray. How we denote reflected ray? By R. Am I clear, students? Is it clear?
Yes, sir.
Now, please remember, see here, the angle of incidence and the angle of reflection, aren't they equal? Isn't it?
Yes, sir.
Angle of incidence and angle of reflection, aren't they equal?
Yes, sir,
Now
they're
see
equal.
here. So that is the second law. So the second law, how you can say, how you can depict the second law?
So the angle of incidence is equal to the angle of reflection.
But that's it. So we can write angle of incidence is equal to the angle of reflection. Angle of deflection. That's it. Okay. Now you was telling at that time, no, that for all surface. Let me tell you, students, one thing. See, in case of optically rough surface, now you see, in case of optically rough surface, in case of optically rough, in that case, what actually happens? In that case, what actually will happen? If you draw a normal here, you will see what? What you will see? That suppose I am drawing a normal over here. You see the angle of incidence is this much and the angle of reflection is this much. Aren't they different? Isn't it? Because optically rough surface, no one can say the light ray will, after reflection, the light ray will go along which direction. No one can say that. Okay, no? So that's why you can't make a rule, a law which can define the irregular or diffuse reflection. So that's why the laws of reflection actually don't follow in case of regular or diffuse reflection. It only follows in case of irregular or diffuse reflection. It only follows in case of regular reflection. Am I clear, students? Yes or no? Tell me. Hello?
But sir, if we draw the normal with respect to the incident and the reflected ray, I mean like this.
Huh?
Uh, uh,
That only I have drawn. See, this is the incident ray. Okay, no? And this is the reflected ray. This one is the incident ray. This one is the reflected ray. Okay. So you see, their angle is different, isn't it?
oh, okay, okay, sir.
Angle is different, isn't it?
Yes,
So
sir.
that's why we say it don't follow in irregular or diffuse reflection, but it follows absolutely in regular reflection. Okay, so whenever it is a regular reflection, in case of mirror or in case of smooth surface, it will follow. Am I clear, students? So these are the first law and second law of reflection. Okay, so that was it for for today. Okay, students. So chalo, bye for today then. Okay, so let's meet in the next week.